All right. Whoa. All right. So, section 3. Number 3 is where we started. What's pi over 4 plus pi over 3? Okay. Because we take 3 pi over 12 plus 4 pi over 12 to get 7 pi over 12. Okay. 5. 3 pi over 4 plus pi over 3. 3 pi over 4 is how many pi over 12? 9 over 12 plus 4 over 12 is 13 over 12. 7. Pi over 4 minus pi over 3 is the same as 3 pi over 12 minus 4 pi over 12, which gives you negative pi over 12. 9. Pi over 4 minus pi over 6. Wow, I made my 4 into a 6. Boom, 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 boom. All right. Equals 3 pi over 12 minus 2 pi over 12, which is pi over 12. All right, so there we go. 11. Basically, what two numbers make 75 degrees that are on your unit circle? 45 and 30. Yep. 13. What two numbers make 165 that are on your unit circle? Yeah, a bunch of you said different answers. I'll go with 135 and 30. 135 and 30. 45 and 120. Yep. 15. Pi over 12. What makes pi over 12? Well, it's 4 pi over 12 minus 3 pi over 12, correct? And what's 4 pi over 12? Pi over 3. And 3 pi over 12? Pi over 4. 17. 7 pi over 12. Well, geez, that's easy. It's 4 pi over 12 plus 3 pi over 12, which is pi over 3 plus pi over 4. Okay? 19. Now we're actually doing the actual what we were supposed to do for the assignment, but we needed a lead up to kind of figure out what was going on so we could do the cosine of 15. Well, the cosine of 15 is the cosine of what minus what? 45 minus 30 or 60 minus 45. Either way, you could have gone there. Okay, let's do cosine of 45 minus 30, which is a cosine of 45, cosine of 30, plus sine of 45, sine of 30, which is square root of 2 over 2 times square root of 3 over 2 plus square root of 2 over 2 times 1/2, which is the square root of 6 over 4 plus the square root of 2 over 4, which is the square root of 6 plus the square root of 2 all over 4. Bada bing, bada boom. It's done. Okay? So 19 through what we went 25, right? So the next 3 problems are just like that. 21, the cosine of 105. What'd you use? 60 and 45. Sounds good to me. Cosine of 60, cosine of 45. Minus sine of 60, sine of 45. Which is 1/2 square root of 2 over 2. Square root of 3 over 2. Square root of 2 over 2. So it's square root of 2 over 4, or 4, yep. Square root of 2 over 4 minus square root of 6 over 4 equals square root of 2 minus square root of 6 all over 4. Trust me on that one? Good. Because you should, because I think it's the right answer. All right. Cosine of 5 pi over 12 equals the cosine of 3 pi over 12 plus 2 pi over 12, which is the cosine of pi over 4 plus pi over 6. Okay. So it's a cosine of pi over 4, cosine of pi over 6, minus sine of pi over 4 sine of pi over 6, which is square root of 2 over 2 square root of 3 over 2 minus square root of 2 over 2 1/2. So it's the square root of 6 over 4 minus the square root of 2 over 4, which equals the square root of 6 minus the square root of 2 all over 4. Last one. Cosine of 13 pi over 12, which equals the cosine of 9 pi over 12 plus 4 pi over 12, which is the cosine of 3 pi over 4 plus pi over 3, which is the cosine of 3 pi over 4 cosine of pi over 3 minus sine of 3 pi over 4 sine of pi over 3. Cosine of 3 pi over 4 is negative square root of 2 over 2. Cosine of pi over 3 is 1/2. Sine of 3 pi over 4 is positive square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. So it's negative square root of 2 over 4 minus square root of 6 over 4, which is negative square root of 2 minus square root of 6 all over 4. But when you take your final test, what they'll do is they'll put the negative out in front, and they'll go square root of 2 plus the square root of 6 all over 4, because your final test is a Math Excel test. So they'll do something like that to you. Okay, but it will be multiple choice for that one. You just have to pick out the right one. Okay, hey, that was your assignment. We just whipped through that really quick. Note card, get out your note card. Sum and difference of sine. This looks very similar to cosine. The sine of A plus B equals the sine of A cosine of B plus cosine of A sine of B. Sine, cosine, cosine, sine. So if we have the sine of A minus B, it's again sine, cosine, cosine, sine. So when you do this, whatever sign is inside the parentheses, a plus sign or a minus sign, that's the same sign that you use when you write it out. Okay, that's a sum and difference formula of sine. The sum and difference of tangent is totally different than that. The sum and difference of tangent, if we have tangent of A plus B, is tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. And the tangent of A minus B is the same thing, it's just the signs are switched around. So it's the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. Okay, ready for examples? Okay, this stuff doesn't go on your note card. You don't put the examples on your note card. Let's take an easy one at the start. The sine of 195 degrees. 195 degrees on your unit circle. 195 is not on your unit circle, but you could take 150 degrees plus 45 degrees. 150 plus 45. So we'd go the sine of 150, sine of 45. Ooh, no, you don't. Cosine of 45 plus cosine of 150, sine of 45. Sine, cosine, cosine, sine. Okay, so what's the sine of 150 degrees? Square root of, no, that's just 1/2, isn't it? Positive 1/2. Yep, positive 1/2. Cosine of 45 is square root of 2 over 2. Cosine of 150 is negative square root of 3 over 2. Sine of 45 is square root of 2 over 2. So it's square root of 2 over 4 plus, plus a negative. So we'll just go minus square root of 6 over 4, which is square root of 2 minus square root of 6 all over 4. Are we good with that? Same as cosine, right? You're just following a slightly different formula. Okay? So, do I need to do one with like a 5 pi over 12, or are you good with that? Good? All right. Tangent's different. Now, tangent. Try to use 60 degrees, 120 degrees, not 30 degrees or 150 degrees. Because it's easier. Trust me. It's a lot easier when you use 60 degrees or 120 degrees or pi over 3 and 2 pi over 3 than it is to use pi over 6 or 5 pi over 6. Trust me, trust me, trust me. Okay? I know what I'm talking about sometimes. So let's say we have the tangent of 15 degrees. That would be the tangent of what minus the tangent of what? Oh, whoever said 45 minus 30. Oh, I just got done saying try to use 60 and 120, not 30 and 150. All right. So let's say we use a tangent of 60 minus 45. Now, if we would do a 45 minus 30, I'd show you how difficult it is. But I don't want to show you difficult stuff. I want you to kind of get it down. What's the tangent of 60 degrees? Well, you put the sine over the cosine. So it's the square root of 3 over 2 over 1/2. If you multiply both top and bottom by 2 is just a plain simple square root of 3, right? So that's why you use 60, because 60 is square root of 3. 45 is 1. Okay? So it's the tangent of 60 minus the tangent of 45 all over 1 plus the tangent of 60, tangent of 45. So it's going to be square root of 3 minus 1 over 1 plus the square root of 3. Now, life would be easy if Mr. Bierschbach allowed you to leave radicals in the denominator. But Mr. Bierschbach, he's just not very nice. Okay? So, to get rid of a square root in the denominator when there's addition or subtraction, you have to multiply by the what of the denominator. Conjugate. I like it when people actually know the math terms for what we need to do. Multiply by the conjugate of the denominator. So if we multiply by the conjugate of the denominator, we FOIL the numerator. So it's the square root of 3. Outers is minus 3. Inners is minus 1. Last times last is plus square root of 3. Denominator, 1 times 1 is 1. Outers and inners are going to cancel. And square root of 3 times negative square root of 3 is negative 3. So in the numerator, you get 2 square root of 3's. So it's 2 square root of 3. Minus 4 all over negative 2. To simplify that, it's 2 square root of 3 over negative 2 plus a negative 4 over a negative 2, which is negative square root of 3 plus 2. That is the tangent of 15 degrees. Okay, let's do another one. Let's say we have the tangent of 7 pi over 12. All right. What two things add up to be 7 pi over 12? 3 pi over 12 and 4 pi over 12. I want you to think of this in terms of the radians. So it's a tangent of pi over 3 plus, or pi over 4 plus pi over 3, right? What's pi over 3? How many degrees is it? 60 degrees. Is that one of those nice numbers? Yeah, it is. Okay. So that's what we want to use. So we'll do the tangent of pi over 4 plus the tangent of pi over 3 all over 1 minus the tangent of pi over 4 tangent of pi over 3. Okay, what's tangent of pi over 4? 1. Tangent of pi over 3? Square root of 3 over 1 minus 1 times square root of 3. So when you have 1 plus the square root of 3 over 1 minus the square root of 3, you multiply by the conjugate of the denominator, which is 1 plus square root of 3. So you get 1 plus the outer is square root of 3, the inner is square root of 3, the last is 3 over 1 minus 3. Because first times first is 1. Outers and inners cancel because they're conjugates. Last times last is negative 3. So you get 4 plus 2 square root of 3 over negative 2. If you divide them each by negative 2, it's negative 2 minus square root of 3. Okay. Page 185. 9 through 15, the odds, which are only 4. Yes, 4 problems is it today. Just 4 problems.